I can really see how much it speeds up process because I've had to do projects by hand, and not that it's bad to have all these bells and whistles. When you're only testing one thing, you don't need 110 different options to pick from. So it's nice to be able to create these projects instantaneously.
Charles, how about you?
Yeah, so I think in terms of the tools, we're all well integrated between the operating systems and uh, simulation workbench and the hardware, but we're always sort of trying to sort of optimize that and remove sort of inefficiencies. And that's one kind of good example where we developed some automated code that removed a manual process. But yeah, so I mean, it's definitely something that's kind of always ongoing. Now for FPGA Workbench, we have some bigger ideas coming in the future where we'd like to reduce additional barriers to entry where everybody now is using LLMs to develop code. We're coming up with a mechanism as Verilog and VHDL, the code to program in FPGA are challenging. We're coming up with ways to potentially integrate some of those tools into FPGA Workbench in the future, which would additionally kind of lower the barrier to entry. So there's things that are kind of on our roadmap. But yeah, that's always a goal of ours, is to try and make the blocks more synergized together.
FPGA Workbench, we allow simulating a entire microprocessor inside of the FPGA card, because since FPGAs involve all of the different types of building blocks of computer architecture, we have allowed the customer to take advantage of a pre-existing Intel design where you can create a computer inside of your FPGA. And I'm not exaggerating. It's a full computer inside of the FPGA. And, it's not a big computer, but it can run C code that you create and C programs that you create directly on the FPGA. And so we have created a suite in FPGA Workbench where you can take this C code in software, compile it, and then burn it onto the computer that's existing inside of the FPGA.
Impressive.
It's pretty cool. It's kind of almost like Inception kind of thing. It's like there's layers to it. It's like you got a computer that has an FPGA card inside of it that has a computer inside.
That has a computer. Yeah.
But if you need a computer running calculations or a CPU doing some form of, maybe you're dividing something, or you need to run like a state machine, or you want a program running, but you don't want to commit the CPU on your host computer to doing that program and constantly communicating with the FPGA doing that. It is worlds of help to have that real program, and it's a real computer program embedded into the FPGA.